Hey guys, hope you're all doing good. In the previous videos we have been creating models for each and every component. Now we will be assembling all of our components before we proceed on to the motion analysis. So to get started, click on File, New, and then Assembly and click OK. Now we are going to be importing the components. We'll start by importing the crank first. So let's select the crank component and click on Open, and just feel free to position it anywhere you want. And as we have discussed a couple of times, the first component is automatically going to be fixed. So if you just right click on the component, make sure that you select the float option. So next we are just going to make sure that the temporary axis is visible, and then we are going to select our axis of crank and then the right plane and then click on coincident. Similarly, we are going to select the top plane and then the axis to make it coincident one more time. So then we are going to expand the component and select the front plane of the component, and you're going to select that the front plane of the assembly. You can see that there is some distance. So for now, let's just move the crank, and then we are going to select the front plane of the crank and the assembly's front plane, and then we are going to provide a distance mate. So click this and type in a value of 36 millimeters, and then you can click OK. Make sure that your unit system is in millimeters. So now we are going to be importing the piston, the connecting rod, and the end caps. So let's just select all these components. Make sure that you hit Ctrl while selecting multiple components. So now let's select this particular axis and this axis right here, and make sure that you select coincident. Now move the components and then select the two faces and then click on make coincident. Right now you can see that the connecting rod is in one piece. Now we're going to select this particular axis and then the axis of our crank pin, and we're going to click on coincident. So then what we're going to do is we are going to basically select one face of that connecting rod and match it up against the corresponding face in the crank, but we are going to provide a distance mate. So let's just select these two faces and provide a distance mate and type in a value of 1 millimeter. Right, so this way we are going to position it correctly while having a very small distance between the two faces. Now you can see that the connecting rod does not have the right fillet, and so we are just going to right click and click on open part. So this is a very handy option. Sometimes you have to edit the part on the fly, and this option is useful for that. So let's click on fillet and let's select this particular edge and this particular edge. This one looks like the last one was invalid, so let's just apply fillet radius of 2.7 millimeters to these two edges, and now try selecting the third one. There you go, perfect. And then the last one. Now let's click OK. So now we are going to add one more fillet. So let's just select this particular guy, and then here the fillet radius is not going to be changed, so let's just click OK. Now we're going to save the plot and then we can exit this part. Make sure that you click on yes so that the changes have been reflected in the assembly as well. So now it's time to insert the gudgeon pin and also the piston. So let's click on open and insert one component at a time. Now we are going to insert the wrist pin inside the piston. So let's select this particular axis and this axis and click make coincident. Now you can see that it's actually moving inside and out. We don't want that. So what we are going to do is fairly simple. We are going to select the front plane of the wrist pin. Right, so let's expand the wrist pin, select the front plane, and while holding Ctrl, select the front plane of the piston, and then we are going to click on coincident. This fixes the problem, and we are also able to move both of these two components together. Now we need to make sure that the piston moves only along its axis. So what we are going to do is we are going to select this particular axis and this particular axis and click on coincident. Now with this, our assembly is kind of already there, but you can see that it's still choppy. I mean, all the possible motions are there, but it still doesn't look right. So we still need to add some additional constraints. So what we are going to do is, we are going to go to the connecting rod and click on the front plane. And we are going to select the front plane of the piston head, and we are going to make them coincident. Now with this, we have kind of locked in the position of the piston, but it can still move or rotate about the gudgeon pin. So what we are going to do is, we are going to select the right plane of the piston, and we are going to coincide that with the assembly. So let's expand the piston, select the right plane, and while holding control, select the right plane of the assembly, and then click on coincident. If you don't want to do this, the other thing you can go do is you can click on mates and then click on the right plane of the assembly and the right plane of the piston. Right, both these options are valid, and then click on OK. Now our assembly is kind of complete, so let's just hide the temporary axis. And if we look at this from the front plane, you can see that everything looks correct. So now you should be able to select the crank, and if you manually rotate it, the piston should move in the desired direction. Right, and try to just pull it in several directions. Try to pull the assembly apart to make sure that there are no loose parts or underdefined constraints. Right, so now our assembly is complete. So what we can do is we can proceed to do the motion analysis. So to get started, we are going to make sure that SolidWorks motion is enabled. So go to SolidWorks add-ins and make sure that SolidWorks motion is checked. So click on SolidWorks motion and just click on this upward pointing arrow and make sure that you change animation to motion analysis. So once we have done that, we are going to enable temporary axis. So this helps us select the crank axis so that we can set up a motor. So let's add a motor first and select this particular axis, right? And you can see that the direction of rotation is shown. And we're going to provide a value of 1200 RPM, and then let's just click on OK. Now this translates to 7200 degrees per second. Now we are going to change the frames per second parameter because we are interested in calculating an output for each and every degree, right? And you can do this calculation fairly easily. And we are just going to type in a value of 7200 because we want an output for each and every degree. Now if we have a smaller value, then there is a chance that you can actually miss the location of maximum and minimum volumes. And also while we are here, let's just enable precise contact and then click OK. Next we need to establish contacts. So let's just click on contact, and the first contact is going to be between the crank and the end cap. So let's just say that the material type is steel dry and then click OK. Now we are going to hide the temporary axis and we are going to continue with our contact setup. So now what we are going to do is between the connecting rod and the crank, we are going to add another set of contacts. And then we are not going to be changing the materials. The next contact is going to be between the gudgeon pin and the connecting rod, making sure that the material is the same. And the final contact set is going to be between the gudgeon pin and the piston body. Finally, let's enable gravity. Let's say the gravity acts along y-axis. You can see that there's a little downward arrow, and that's basically it. Now let's take a look at the model from the front view and hit on run calculation. Now this process is going to take some time, right? Because we are storing a lot of values per second. So that's why it's a bit slow, right? But that is the reason why we are getting this really nice and smooth looking animation. So now we are just going to click on stop because 3 rotations of the crank are complete. So now what we are going to do is we are going to plot the linear displacement of the piston. So let's click on results and plots, and category, let's select displacement, and for subcategory let's hit linear displacement, and we are going to be measuring the magnitude. So let's select the top face, and then let's just click on OK. There you go. So when you do this, you actually get a very smooth looking plot for the displacement. Now based upon the bore and stroke, you can convert it into a volume trace as well. Now if we had a lower frames per second, then we might not be able to capture the maximum and minimum value for the linear displacement. In fact, that is something that you should try out. Put in a value of 25 frames per second, the simulation would run fast, but then the results are not going to look this good. So here you can see that the piston moves about 10 centimeters, right? Which is kind of what we initially planned on. So now what we're going to do is, now the next thing that we're going to do is verify if the crank is actually rotating at the right RPM. So go to plots, displacements, and we're going to be measuring angular velocity. Click on magnitude and select this particular component, and then click on OK. Right, you can see that the angular velocity is around 7200. You can see that it's kind of changing a little bit, but if you pay attention to the axis, it is in between 7200 and 7200. Right, so that basically means the RPM is constant. This is something that you need to check because you always need to get the same value that you put into the simulation. Now the other cool thing about this particular software is we can export the plots. So for example, let's just click on this filter results so that we can take a look at only the plots. So let's expand the results and right click on linear displacement, and then you see that there is an option called as show plot. Right, now remember, only when you see the plot you will be able to export it. So when you see the plot, right click again, and this time you can see that there's an option called export to spreadsheet. This process takes a little bit of time, but you should be able to see an Excel which contains the data set. You can use this for further processing if required. You can see that the plots have also been transferred, which is very, very convenient. Alright, with that I would like to conclude this particular video, and I'll see you guys in the next video. Bye.